Hello everyone, welcome to the video lecture series of operating system. In today's session, we are going to continue with the topic memory management. Specifically, we are going to discuss the concept of non-contiguous memory allocation strategies, in which we are going to discuss the second strategy, which is nothing but segmentation. Myself, Ronald Panchal, your instructor. In this particular session, as I told you, we are going to discuss segmentation. So what is segmentation? So segmentation is one of the technique, or you can say method, of non-contiguous memory allocation. Okay, what is non-contiguous memory allocation? That we have already understood in the previous session. With respect to memory management, operating system has two important responsibilities, or you can say functionalities. One is memory allocation policy, or memory allocation we can say, and second one is address translation. These two are the main responsibility of operating system with respect to memory management. And these two different strategies we have already understood in the previous session of paging with respect to non-contiguous memory allocation strategy. So before going to discuss segmentation, I strongly recommended to you to visit my video of paging, because if you don't know paging, you won't be able to understand the concept of segmentation. Okay, so paging and segmentation both are non-contiguous memory allocation technique. That things you to keep in your mind. Okay, now the question is what is the difference between paging and segmentation, and what are the drawbacks we have when we are talking about paging, so that we need to understand the concept of segmentation. Fine. So let us discuss all about segmentation. So before going to discuss segmentation, I am giving you just brief idea about paging, in which we have already understood when programs stored in secondary memory, that programs are divided into a fixed size pages. Okay, so logical address space is divided into a fixed size partition, and each partition is called as pages. Okay, when any of the program wants to execute in the CPU, that program needs to be loaded into main memory first, because you already know if CPU wants to execute any process or basic program, that program needs to be loaded into a main memory. Fine. So that we have already understood in paging as well. So that fixed size partitioning scheme in the case of secondary memory called pages, and once that pages is loaded into main memory, okay, so that pages would be called as frames, and size of frame and size of pages are same, that we have discussed already. Fine. So, and both in that case we are using fixed size partitioning scheme. Fine. So who is responsible to do a partition in that case? The operating system itself will do the partition. Okay, there is no intervention of user or any compiler in the case of paging. So that's why the paging technique is somewhat faster than segmentation. That justification we are going to discuss in upcoming slides, but these things you have to keep in your mind when we are talking about segmentation. So Again, in the case of segmentation, the frames that we called in paging technique, that same frame we called in this case as a segments. Fine. So let us discuss that stuff in detail. So what is segmentation? So with the help of one figure, we are going to discuss the segmentation in detail. So this figure tells us the logical view of segmentation. Okay. So as I told you, segmentation is one of the technique of non-contiguous memory allocation. So first of all, in this particular slide, we are going to discuss the first responsibility of operating system with respect to memory management, which is nothing but memory allocation. Fine. And in the next slide, how we can do the address translation in the case of segmentation that we are going to discuss. Fine. And then we will discuss how segmentation differs from paging. Okay, so let us start with the logical view of segmentation, in which we are going to discuss memory allocation policy. Okay. So because it is one of the technique of non-contiguous memory allocation, so definitely the allocation would be non-contiguous fashion only, right? So you can see in this particular figure, there is one box, okay, at your left hand side, logical address space. So logical address means what? That caption of that block is what? Logical address space. What it means? Logical address space means what? It is nothing but your secondary memory. Okay. So in the case of paging, the secondary memory is divided into fixed size partitions, and each partition we called as pages. But in this case, the logical address space is divided into a variable size partition, and each partition we called as segment instead of pages. This is the difference. Okay, and what is the significance of this variable size partitioning that we are going to discuss right now? In the case of paging, see, for irrespective of the size of the process or piece of program, the operating system will simply divide that process or piece of program into a fixed size partitioning scheme. Okay, but in the case of segmentation, the operating system will not take care about this partitioning policy. It means what? The partitioning would be performed by the compiler, or there's a user intervention is required in this case. Means partition will be performed by the user or there's a compiler itself instead of operating system. Okay, so how these partitions would be performed and what are the advantages? So let us take one example. Suppose if we have a program or this process in which, let's say for example, there is one program of calculator. Okay, and in which there are various functions like one of the function is addition function, second one is subtraction, third one is multiplication, fourth one is division, and so on. So this is one program of calculator. Okay, if you are using the paging technique, so that program is simply divided irrespective of where that addition function is started and where it is completed. Irrespective of that stuff, this operating system will simply divide that whole program into a fixed size pages. But in the case of segmentation, what will happen? If you are talking about same calculator program, it means what? The segmentation would be performed by the user. So what user will do, or you can say what compiler will do? Compiler will do the partitions based on the similarity of the code. Means addition module if we have, so addition module we will put it into one segment. Then subtraction module we have, that we will put it into another segment. Then multiplication segment we have, the whole multiplication module we will put it into a separate segment. So what will be the advantage in this case? So in the case of paging, suppose if addition is, definitely in that case there are chances if addition module we have, that can be divided into two different partitions. So once the first partition is executed by the CPU, then CPU needs to immediately call the second page, which is required to execute the addition module. Fine. And if that page is not available at that point of time, there are chances of page fault. But in this case, what will happen? So partial execution of that code can be possible, and remaining execution cannot be possible, or it can be a time-consuming process. That is the case when we are dealing with paging. But in this case, the whole addition module is included into a separate segment. So if segment is present, definitely the whole addition module will be executed by the CPU. Fine. There is no concept of partial execution of a particular module in this case. Okay. So if that page is available, there is no page fault in the case of segmentation. Fine. In the main memory, we already understood what is page fault. If required page is not available, okay, in main memory, and we are somehow we can manage to get that page from the secondary memory and put it into main memory, that procedure is nothing but a page fault. Okay, so you can see logical address space is divided into a various size of segments, like you can see segment 0, segment 1, segment 2, segment 3, and segment 4, and each segment have different size, right? So because it uses variable size partitioning scheme, definitely sometimes addition code require less number of instructions for execution. So definitely it will be put into a separate segment, and subtraction or multiplication require more number of lines or case instructions for execution. So definitely it will be put into a separate segment as well. So the size of the segment can be different in this case, which is not possible in the case of paging, because the logical address space is divided into a fixed size partition policy. Okay, in this case we are using variable size partitioning. So first block is over. Now once this segmentation is performed at secondary memory, now the first responsibility of operating system with respect to memory management come into the picture. Which one? Memory allocation. Means now these segments needs to be loaded into a main memory. So how we can put it into main memory? So again we are you can see one more block we have. Okay, the caption of that block is physical address space. Fine. So physical address space means what? It is nothing but a main memory, because main memory can be accessible with the help of physical address only. So that's why it is called as physical address space. Clear? So these various segments starting from 0 to 4 needs to be loaded into a main memory. Then these segments can be executed with the help of CPU. So first of all, you need to load that segments. So segments can be loaded into the various space that are available in main memory at various positions. Because we are dealing with non-contiguous memory allocation, there is no sequence. Okay, whenever any segment find the enough space to accommodate into main memory, it will be accommodated easily. Fine. So segment 0 is located first, then segment number 2, then segment number 1 you can see, then segment number 4. There is no ordering. Okay, because it is non-contiguous. Fine. Now one more thing we have. You can see in the main memory there are some values, and that values bounded values we have is what the lower bound, or this is starting value and the ending value of each segment is given. So what that value means? So let us discuss the one more data structure that we are going to use in segmentation is nothing but segment table. As we have discussed, page table in paging, same way in the case of segmentation, we need to have one more data structure which is stored in main memory itself. That is nothing but segment table. And segment table can be also considered as you can say index table. Okay, so segmentation table contain two fields. One is base address and second one is limit. Okay, or you can say range of that particular segment. So base address means what? Base address denotes where the particular segment start. So that there are various base address has been mentioned, like first one is 500, then 2500, then 1500, then 4600, then 3800. There are this is the base address, right? And limit means what? What is the total size of that particular segment? So that we call as limit. Okay. So and the index value, how we can fetch the base address of a particular segment. So with the help of segment number that is given to us in the segment table. So segment number is given 0, 1, 2, 3, 4. You can see. So these are the different segment numbers that we have. So how many segments we have? You can see in the physical address space, or as well as in the logical address space, there are various segment numbers starting from 0 to 4. So 0 to 4 segment numbers are there. Okay, and each segment number, with the help of that segment number, we can reach to the base address of a particular segment. Base address is nothing but a starting address, we can say. Okay, of starting address of a particular segment. Fine. So these things you have to keep in your mind, because based on this understanding, we are going to discuss the next figure. Okay, in the next slide. So now again we need to come to the physical address space, in which we have the index values, or you can say bounded values we have for each segment. So that bounded value is nothing but the starting address and ending address of each segment in main memory. So segment 0, you can see the starting address of segment 0 we can fetch from the segment table. So starting address of segment 0 is what? 500. So it will start from 500. And what is the limit? So what is the total size of the segment 0? Say for example, if you are talking about in terms of bytes, so 600 bytes are there. So 500 plus 600 is equal to 1100 bytes are there. So what is the size of segment 0? 5. It will start from 500 and end with 1100. Same way segment number, say for example 1, it will start from 25000 and it will end with what? 3300, because the size of this particular segment 1 is 800. So 2500 plus 800 is equal to 3300. So in this way, we have mentioned the range of each segment. So up to this, I hope it was clear to you, because based on this understanding, we are going to discuss this next slide. Okay. So this is all about memory allocation. Now the second responsibility is what? How? Now we have loaded that segments into main memory. Now CPU can access this. CPU needs to access this main memory. But to access this main memory, CPU requires to compute, because CPU always returns logical address. So, and with the help of logical address, we cannot communicate with the main memory. So somehow we need to have some mechanism through which we can convert that logical address into physical address, so that the CPU can contact with main memory directly. So that addressing mechanism, or that address translation mechanism, we are going to discuss in next slide. Okay. So you can see in this particular figure, as I told you, CPU, there is one CPU will always iterate logical address. Okay. So this figure is somewhat you can say similar with paging figure, but there are some changes you need to understand. So CPU always iterate logical address, and logical address contains two parts. One is segment number. In the case of paging, the page number was there, but in this case, because instead of page we are called that partition as segment. So that's why segment number, S stands for segment number and D stands for displacement or offset value, or in this case limit, we can say limit. Fine. So CPU generates this logical address, okay, and CPU require, say for example, a particular segment number. So that segment number will be that requested segment number will be forwarded to the segment table. Fine. First, so segment table will have this information regarding this particular segment. Okay. Now the next thing we need to check. This is, you can say, at bottom side we have one decision making symbol. Okay. So what it means? So D, the value of D will be forwarded to these, and condition will be checked. D, whether D is less than limit. What it means and why we need to check these things. So D stands for, as I told you, the limit. So we need to check because each fragment size is already loaded into a main memory. It is already loaded into main memory. Fine. And the size of that each fragment or segments are finalized. Okay. So now there is no change of the size of the segment because it is already loaded into a main memory. Now, if CPU requested to a particular segment with its size, so we need to check also with the help of a particular segment number if CPU is demanding more than that actual size of that segment or not. So that we are checking in this particular case. So D stands for, as I told you, this limit or the size of that segment. If CPU is, say for example, demanding, say for example, page number, segment number 1 and segment number 1, for example, the total size is, say for example, 300 and CPU demanding 400. So definitely this condition will not be matched. Why? Because D, what is the value of D? Means demanding value is 400 bytes, but the actual size of that segment is that we can fetch from the segment table. So you can see the limit value will be compared in this case. So this condition is not satisfied because the requested size is larger than the actual size of that segment. How it is possible? How we can fetch that data if that size of data is not available in the main memory? Yes. So in that case, if condition is false, definitely the error needs to be generated. Means what? One interrupt or trap would be generated, or we can say error. Okay. So that is the false case. But what will happen if CPU demanding, see for example, 200 bytes of segment 1 and the actual size is, say for example, 300. So definitely this condition would be true because demanding size is less than the actual size of that segment. Yes. If condition is satisfied in that case, what will happen? This offset value, or we can say limit value, say for example 300, would be appended with the help of that base address of the segment. So segment base address and this limit, its total limit, so that we can access the whole block or the whole partition of the main memory that we called as segment. Because segment is nothing but we need to have the base address, and with the help of base address, once you have the base address, then you have to calculate the requested set of bytes that we can easily fetch with the help of this D value. So these would be appended and send it to the main memory. So based on the base address plus limit, we can CPU can fetch this information and execute it. Okay, and according to that, it will display the output. So in this way, this segmentation technique works. Okay. Now Once you understand this paging and segmentation very well, now we are going to discuss the difference between paging and segmentation. So let us discuss the difference between paging and segmentation. So in this particular figure, you can see what is paging and what is segmentation. What is the difference between these two? So both are non-contiguous memory allocation strategy. Yes, both are non-contiguous memory allocation strategy. Second difference is what, as I told you, the paging. In the case of paging, the partition would be performed by the operating system itself. But in the case of segmentation, segmentation would be performed by the compiler. It means what, user intervention is required in the case of segmentation. Right? The third difference is what, paging divides program into fixed size pages. In the case of paging, we are using fixed size partitioning policy or case scheme. But in the case of segmentation, we are using variable size partitioning policy. Okay. The fourth difference is what? Definitely, user intervention is not required. So definitely, as I told you earlier, paging is faster than segmentation, whereas segmentation is slower than paging because the segmentation will be performed by the compiler itself. So it means what? User intervention is required. Same way, the another difference is paging is closer to operating system, whereas segmentation is closer to user. Right? So that's why it is somewhat slower as compared to paging. Okay. Paging, it suffers from internal fragmentation. Why? Because we are dealing with fixed size partitioning policy, and you know very well. You can see my previous videos of memory management, in which I have already explained. If you are going for fixed size partitioning scheme, definitely you will suffer from internal fragmentation. Whereas in the case of segmentation, if you are going for variable size partitioning scheme, it may suffer from external fragmentation. Okay, and logical address is divided into page number and offset in the case of paging. Definitely, as I told you, CPU generates logical address, and that logical address is divided into two parts. One is page number and second one is page offset in the case of paging. Whereas in the case of segmentation, the logical address which is generated by the CPU is divided into two parts. One is segment number and another one is segment offset. So in this way, the non-contiguous memory allocation policies or cases schemes works. Okay, I hope it was clear to you. Thanks for watching this video. See you in the next one.